Hi everyone, my name is Priyakshi and today we're speaking with Akash Gupta and Abhinav Roy from Clean Electric. Clean Electric is a startup working on advanced battery solutions for electric vehicles, and it claims to support ultra fast charging without any compromise on battery life or battery safety. So in this chat, the aim is to understand more about their work and its implications. So thank you Abhinav and Akash for joining me today.
Hello. Thanks a lot, Priyakshi, for having us here.
Sure, it's my pleasure. So, can we start by a brief about your energy storage solution and what kind of IP you are building in battery technology space?
Right. So we as a company believe that thermals are very important to really be able to deliver the performance that a cell is capable of. And in order to basically enable all of that performance or unlock all of that performance on a battery pack level, we have built our proprietary thermal management solutions. What these solutions aim to achieve is to basically enable the ideal operating thermal environment for a cell under different conditions. Say when a cell is fast charging, it requires certain different thermal conditions. When a cell is idling, it requires certain different conditions. When it is on the road driving a vehicle, it requires different conditions under different basically operating parameters. So when you're climbing a hill, you would want a certain different thermal profile. So we have built a very efficient and basically a very uniform thermal environment for all of the cells present in a battery. And that enables us to basically supercharge the performance that is being delivered by all of these cells in the battery packs that are today out there today. So we don't require any specialized chemistries. We don't require chemistries that are more expensive, that are more difficult to fabricate. We take cells that are being mass produced today, and we add a thermal solution onto those cells to basically enable them to perform at a much higher level. Performance in what terms? Performance in terms of fast charging that we can deliver, performance in terms of the usable cycle life that those cells can deliver. And we also consider safety to be a very important parameter. So let's say we take an NMC cell, and once we bolt on our thermal solution to that NMC cell, it's as safe as, let's say, an LFP chemistry.
Okay. Okay. So when we recently had some fire issues a month before, so
Right,
there were reports that the cells that were used in the vehicle itself were not up to the mark. So it's
right.
very much a possibility that going forward also, people keep importing cells without really a visibility into the quality of all the cells that they are importing.
Very true.
And how we say that the weakest cell will determine the overall performance of the battery.
Yeah.
So
Right.
how will your system take care of cases like that where one or two cells in the pack are bad?
Right. So basically, to add to that, we don't just supply the battery thermal solution, we build the entire battery ourselves. So we have a certain degree of quality control that we can do on the cells. We can obviously not go out and improve the cell supplier's processes or basically his fabrication methods, but we can certainly have a certain degree of quality control. And adding on to that, the problem with all of these incidents is that these incidents were not controlled. Say, let's say that there are 300 cells in a battery pack or 400 cells in a battery pack. What happens is that there is always a chance, no matter who you source it from. Even Tesla sources them from Panasonic, and they have had cases of thermal runaway. The problem is that in the battery packs we have today, that thermal runaway is not controlled. Once there is a thermal runaway in one of the cells, it starts to propagate, and the entire battery basically goes into a thermal runaway. What
Mhm.
we have done is that we have built a thermal solution that is very capable of controlling that thermal runaway or limiting that thermal runaway to just that one rogue cell. It
Mhm.
does not propagate to all of the other cells. So yeah, the battery will lose performance, obviously, because one of the cells has now died, but it will be a limited event that can be later on taken care of at the service center. It won't really balloon into a safety event like the kinds we have seen.
Okay. Okay.
And we have testing for all of these cases. We can also share the videos later on. So
Mhm.
we have tested for, let's say, an overcharge scenario where in a battery pack, let's say 3 or 4 of the cells go into overcharge due to certain imbalance or certain fault on the chargers, and let's say. And our solution is very capable of dissipating all of that heat that is being generated in those fuel cells and controlling the damage that is being done.
Okay. So here to control and dissipate that heat, what kind of cooling mechanism are you using?
Right. So we have different solutions for different vehicle classes.
Okay.
For a two-wheeler application, what we have is that we have all of the cells immersed in a dielectric coolant. We have certain ways to move that fluid around the battery and bring all of that heat out to the battery casing. And once we have it at the battery casing, we can have different methods of dissipating it out to the environment. So certain vehicle manufacturers who really want a very fast charge rate, they can also have external fans on the battery. In let's say a swapping station, we can have additional thermal methods where we can have, let's say, refrigerated air around the battery packs when they're really fast charging it up in, let's say, 20, 25 or 30 minutes. So yeah, we bring the heat out to the casing in a standardized way across our product lines, and from there on we differ in how we really deal with that heat based on the application.
Okay. And the method of cooling is called immersion cooling. Is that correct?
Right. Yeah. Yes, actually, that is right. So we have a dielectric coolant, and that dielectric coolant basically it has a very high dielectric strength. So it can be in contact with the fluid, and there is no conduction of electricity through that fluid. So we immerse all of our cells in that dielectric fluid, and it allows us to very efficiently extract the heat from the cells because all of the surface area of the cell is in contact with the coolant.
Okay. Okay.
Yeah.
And this technology, what kind of validation have you received so far from any OEMs you've tested with or any regulatory agencies?
Right. Akash, would you like to take that up?
Yeah, sure. Abhinav. So there are multiple ways in which we have to validate the technology. The first and foremost comes the in-house validation before giving out to the OEMs, and then you have to get the regulatory approval in order to uh, get FAME subsidy or state subsidy on electric vehicle, which is per kWh. So recently, one of our customer battery packs has been certified by ARAI as per AIS 156 testing regulation, which is a list of maybe 20 tests which the government agencies conduct on the battery pack to ensure the safety, reliability of the packs. And these AIS 156 is valid for both two-wheeler and three-wheeler use case. So passenger, cargo, L5, and all kinds of two-wheeler. And apart from this, we have been building this battery technology for 2.5 years now, and it's very much matured, and it has gone through series of iteration, and which has resulted in very good performance. I will say it was a theory couple of years back when we were speaking with folks from Mahindra Electric and other big automobile companies. So they were all like, immersion is a good thing from a paper perspective, research paper perspective, but it has its own challenges and it will increase weight, it will increase cost. But the team has spent 2.5 years to solve all the integrities and to have a technology which is at par with other conventional battery pack technologies. And number of OEMs in the two-wheeler and three-wheeler space have validated our technology. We have sent samples to top 10 EV OEMs in the two-wheeler, three-wheeler space in Bangalore, in Gurgaon, in Vadodara, and other places in the country. Several of battery packs are, as we speak, are undergoing testing at different OEMs. We have NDA, so we cannot disclose names, but in different parts of India, they are currently being tested, and we hope to start production by December of this year at scale from our Pune factory.
Okay. Okay. All right. So, you start production in December. If you can talk about how you are building up your manufacturing capability, what is the scale and what is the current setup that you're working from?
So the current setup is more geared towards R&D and pilot battery packs. So you can say we are able to do 50 packs on monthly basis for different OEMs, so that we are able to get the full design validation done with OEMs, with certification agencies and things like that. But the actual automated production line we are setting up in Pune Chakan area, and it's 12,000 square feet production area, which will be capable of producing 1,500 to 3,000 battery packs on monthly basis if we operate in one shift or two shifts. So that is the kind of capacity we are building for this year. Next year, we will be increasing the capacity. It is just the pilot production setup basically. And the next year, we'll be increasing the capacity to 15,000 packs on a monthly basis towards the second half of next year.
Okay. All right. And what will be the cost implication? Because it's a new technology, cooling technology is new, your thermal management, and you are supplying the whole battery pack. So as an OEM, how much hit do I take on my procurement costs when I go with you in comparison to the regular battery pack manufacturers?
Right. In a country like India, Priyakshi, if you really have to sell something, it has to be cost effective. So people in India are not going to pay you 2x or 3x just because you are providing fast charging or you are providing fireproof battery packs. So that is not enough. The problem and the challenge which we were solving for the past 2.5 years was how do we make it cost effective? How do we make it light? How do we make it compact so that customer don't say, I don't have that much space. So right now, our battery packs are domestically and globally competitive, and we are hardly adding. If you talk about two-wheeler packs, we are hardly adding 1.5 to 2% cost as compared to conventional air-cooled battery packs. But we are not thinking in terms of cutting cost and eliminating some of the bill of material, which is very critical for safety.
Cost.
So that 2% cost delta is there, but when OEM or a customer understands the value proposition, what they are getting, complete peace of mind from an end customer perspective. The benefit we are enabling with a cost efficient technology, and you are able to get 25 minutes charging time without paying 3x or 4x cost, which you have to pay in specialized chemistry, ultra capacitor, LTO chemistries for fast charging and safety. So here what we are doing, we are using mass produced, affordable, proven NMC, LFP, NCA types of cell chemistries and putting our technology of immersion cooling and STM on top of it. And through the combination of hardware software, we are able to boost the performance without taking any hit on cycle life.
Okay. So, and any industry practice that you want to highlight in your experience in the industry in last few years that need correction with respect to specifically battery pack manufacturing and integration?
Right, Prakshi. So, yeah, we have basically dismantled quite a few battery packs in these years. And a few things that we noticed is that there is this, let's say, a lack of cell level fusing protection. So, what this again adds to is that even if one cell fails, it will lead to a runaway event throughout the battery. So this is one basic protection that's missing. Then there's a complete lack of thermal solutions around a battery. In most battery packs, there are obviously battery packs that do take this into account. Then there are also battery packs which are IP rated, but they're only IP rated when they're basically off the shelf when they come out new. With just a bit of abuse, they lose the IP rating, and then there's water ingress and all sorts of things. So there are these things as well. Mostly these things, right? There's also probably a lack of vent plugs on certain batteries that we have seen, and that again is a pretty major safety risk, because once a cell goes into thermal runaway, it releases a lot of gases, and there needs to be a safe way to basically vent that out into the atmosphere. So yeah, these are pretty simple things to take care of. Yeah.
Right. But do the current standards for batteries, do they not check for any of these flaws? Because these, like you said, when you disintegrated those batteries, you could point these out.
Uh, right. So again, the rules are basically test it out on performance on certain tests. Now, there is no test currently that forces a thermal runaway in a cell and checks as to how that runaway progresses through the battery, right? Because it is also a difficult to conduct test, as in to put one single cell into thermal runaway in a controlled manner is It's not too difficult, but yeah, it requires a certain setup. People can do it. If there is a regulation that comes out that says that you have to put a certain cell into thermal runaway and then check for the propagation, how that progresses. That test, people will have the equipment that will be incorporated, but it's not there right now. So right now, it's more about checking out the boundaries as if have the basics being done right, and certain things do get left out.
Okay. Okay.
Yeah.
Understood.
But Priyakshu, just a small addition to that. Regulations are there for hygiene checks basically, but at the end of the day, nobody has told Maruti that you have to make a reliable product. Nobody has told Toyota that or a Volvo that your car has to be safe. So it's the responsibility and DNA of different companies to not ship unsafe products basically. So there was nail penetration earlier in AIS 48. Now we have the revised version AIS 156. And in AIS 156, nail penetration has been removed because it's almost impossible to do a nail penetration with conventional battery packs, basically, because all the two-wheeler works on NMC and CSLs as we speak. Because you have weight constraint, you have space constraint. So it is impractical for a NMC pack or a Panasonic cell or a Samsung cell to pass a thermal runaway or a nail penetration test technically. So any NMC cell, we have done nail penetration in our labs to test the safety of our packs. We have done overcharge at our labs. So it's impossible to control fire in an overcharge scenario in case of NMC based cells. And for that matter, LFP as well. So at the end of the day, that is where the experience come in. And that is why we need specialized battery companies who have 3-4 years of experience of working on battery packs and understanding the nuances. Like Abhinav was mentioning, to avoid a thermal runaway event in a battery pack is a very difficult task. And every OEMs has its own way of dealing with it. Like people have aluminum fins in between two cells so that the fire in one series of cell does not propagate to another. So people are doing, Tesla is doing that, Ather is doing that. So Ather packs are very good from thermal runaway scenarios because they've spent the time and the resources needed to get to that safety level. But that is missing. We have not seen other packs following such principles. Nowadays, people are putting PCM and other things, but that is lacking in the industry.
Right. Yes, Akash, and one last question. You said you performed nail penetration test in your lab on your own battery. What was the result?
Abhinav, you want to take this?
Right, sure. So, Priyakshi, it's a bit difficult to explain. We'll share the video. That'll be pretty apparent. But in a few words, what we had was that we set up two parallel demos. One was without immersion cooling. One was with immersion cooling. In a nail penetration without immersion cooling, we had fire and smoke, the usual. And in a battery pack that had immersion cooling, we basically fabricated transparent battery packs for just this test. In the battery that had immersion cooling, there was just cold smoke, no incident of naked fire, and we also had other cells around the one failing cell as well. So those cells were also pretty safe from the event. There was no propagation of that event.
Okay. So thank you so much, and I really I look forward to seeing the vehicles on road. And when that happens, we will connect again and evaluate the performance and the feedback that you guys get. So thank you so much and all the very best.
Thanks a lot.
Priyaksha.
Thanks a lot, Priyaksha.